Today we're going to take a look at taking the derivative of this function, and we have a binomial times a binomial. So there's two different ways that you could take the derivative. You can take the derivative using the product rule, which is, if we have, this is f of x, or let's just call it, it's all one function, but let's just think of it as in terms, like this term and this term. So what you could do is you could do derivative of the first times the original second term, plus the original first term times the derivative of the second term. So you could take that route. Another potential route is actually just multiplying the polynomials together. Like just doing x to the 1/3 times x to the 1/3 times -5, and then doing this. You could do that also. That's another possibility. So there's two different ways that you could do this. Let's just go with the route of just using the product rule, I guess. I don't know. No right or wrong way. You could do both and you'll get the same answer. But let's just go this route. So I'm going to take the derivative of the first term. So that's going to be x to the 1/3 plus 1. So I'm taking the derivative of that. So the derivative of, I'm going to call this f of x. I know the function is called f of x, so I should have used some different language, but that's okay. So this is going to be 1/3 x. So x to the 1/3 is 1/3 x minus 1. So this is over 3, and that becomes 3. 1 minus 3 is -2/3, and that's something more you do. It's just like 1/3 minus 1, boom, -2/3. Like you just get pretty quick with that, but if you need to write it out, that's what it is. It's just 1/3 minus 1. So this denominator becomes 3. This also becomes 3 then. So 3 over 3 is what you're doing. 1/3 minus 3 over 3, which is -2/3. And then 1, derivative of 1, is just a constant, so that's 0. So that term is gone, so the derivative of 1 is 0. So I get, for that, f prime of x, just 1/3 x to the -2/3. So I'll have 1/3 x to the -2/3. And that is being multiplied by g of x. G of x is x minus 5. Plus the original first term now. So this is x to the 1/3 plus 1 times the derivative of the second term. So the derivative of the second term is going to be the derivative of x is just 1, because this is x to the first. This becomes 1x. 1 minus 1 is 0. So we just get 1. X to the 0 is 1, so you just get 1. So derivative of g prime, or the derivative of x minus 5 is just 1, because then again we have a constant. The derivative of a constant is 0, so we just get 1. So that whole term is 1. So the second term, the f of x times g prime of x, the original first term times the derivative of the second term, not too bad, because we just end up with the x to the 1/3 plus 1 times 1. So that's just going to be x to the 1/3. Let me write that. X to the 1/3 plus 1. Over here, though, on the left side, a little bit more work. So we have to do 1/3 x to the -2/3 times x, 1/3 x to the -2/3 times 5, times -5. So let's do 1/3. Put this down a little bit. So this is going to be 1/3 x to the -2/3 times x to the first. Multiplying by the same base, we add the exponents. So you want to do -2/3 plus 1 over 1. So this is going to become 3 over 3, just like how it did before. When we were taking the derivative, we were subtracting 1. Now we're adding 1, and we get back to x to the 1/3. So that's going to be x to the 1/3. Don't forget about the coefficient of 1/3, because it was 1/3 x to the -2/3 times x. This times this, x to the -2/3 times x, becomes x to the 1/3. Well, we still have that coefficient, because 1/3 times 1 is 1/3. Let me erase some of these markings here. Okay, then we have 1/3 x to the -2/3 times -5, so that's going to be -5 over 3 x to the -2/3 plus x to the 1/3. Let me rewrite this, make it a little bit neater, and then we will do some simplifying potentially here. Let's see. And there's always this weird line of how much do we clean it up, like how much, like what is okay, what is not okay. That's mostly dependent on textbooks that you're looking at or teachers that are going to be grading your work, like what are they exactly looking for. But we can do some simplifying here, like some pretty clear, I have an x to the 1/3 and x to the 1/3, so I do want to actually combine those. So let's do that. So I'm going to combine 1/3 and 1, the coefficient of 1/3 and 1. So I'm doing 1/3 plus 1. 1/3 plus 1, 3/3. So this is going to be 4/3. So 4/3, and I'll write this as 4x to the 1/3 minus, be careful here in this next term. So I'm going to clean this up. I'm going to write this as 5/3, but where does the x go? Because it's x to the negative 2/3, that needs to come down. So this is going to become x to the 2/3. And then we already simplified that, and then I do have this tacked on 1 over there. Yeah, I'm going to leave it alone here. Like, there's definitely some more simplifying that can happen if you absolutely wanted to, but in terms of just taking the derivative here, I think we're good. I think this is going to be plenty for what I would consider a pretty reasonable answer. Like, there's no negative exponents. We combined all the like terms, so let's just leave it at that. So, and again, I went the route of just using the product rule here. You don't have to. You could have multiplied it out, and we would have still gotten the same type of weird, messy answer, but you could have technically also done that.